Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems based on the concepts on vectors in R square. So let's start with the problem on the left side. So for A, -1, 3 and B, 2, 5, draw a coordinate plane and place the points on the graph. And in part A, draw vectors AB and BA and give vectors in the component form equivalent to each of these vectors. So let's start with part A. So first we have to draw a coordinate plane and place the two given points A and B. So point A is -1, 3 and that will be here. And point B is 2, 5 and that will be here. Now in part A we have to draw vectors AB and BA. So vector AB starts at point A and ends at point B. So this is vector AB. And vector BA starts at point B and ends at point A. So I can use a different color for it. So this red vector is vector BA. So it starts at point B and ends at point A. And now we have to give vectors in component form equivalent to each of these vectors. So let's start with vector AB. So vector AB can be broken up into position vectors for A and B as so we always do the position vector for the second letter in the vector minus the position vector for the first letter in the vector. And now we can write the position vectors for A and B, which will be the given points. Now we can subtract these position vectors. So for that, we'll subtract the x components and the y components. So 2 minus -1 is equal to +3 and 5 minus 3 is 2. So this is vector AB in component form. Now we can calculate vector BA. So we'll break up vector BA into its position vectors. And the position vectors for A and B are the given points. Now we can subtract the x and y components. So this is vector BA in component form. So we are done with part A. Now we can analyze part B. So we have to determine the magnitude of position vector OA and magnitude of position vector OB. The magnitude of a vector is calculated by squaring the x and the y components of that vector and then adding the results and then apply square root to the sum. So first we'll write vector OA, and vector OA is equal to the given point, and now we can find the magnitude of this vector. So negative 1 square is 1 and 3 square is 9. And this is equal to square root of 10. So this is the exact value for magnitude of vector OA. Now we can do the same analysis for vector OB. So first we'll find vector OB, and that will be the given point B, and now we can find its magnitude. So this is the magnitude of position vector OB. Now we can do part C. So in part C we have to calculate magnitude of vector AB. So first we'll write the vector AB that we found in part A. Now we can calculate its magnitude. So we'll square the two components, add the result and apply square root to the sum. So this is the magnitude of vector AB. Now we can find the magnitude of vector BA. So for that we'll use vector BA from part A. So we got vector BA equal to, so for the magnitude we'll square the components, add the squares and then apply square root. So negative 3 square is 9 and negative 2 square is equal to 4. So we got the same result because vector AB and BA are just vectors in the opposite direction but have the same magnitude. So now we are done with the first problem. Now we can analyze the second problem. For the vector OA equals 3i minus 4j, calculate the magnitude of vector OA. So this vector is given to us in unit vector form. So we can write it in the component form as Now we can calculate the magnitude. So we'll square the components and add them and apply square root. So 3 squared is 9, negative 4 squared is equal to 16, so this should be the final answer for the second problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.